Welcome to the second lab for EC114. Today we'll look at some of the data syntax you need to get used to, and we'll look at some of the basic commands for plotting variables and getting to know your data matrix overall. So we will start by setting up our working directory in the same manner that I explained in the last lab. We'll also open our log file. I forgot to mention that every time you finish a session, you should close your log file, which I didn't do in the last video. You simply close the log file you're using by typing in log close. And if you run this, you will close your log file and store all the information in the file you created here. So here we'll close any log file that can be open, so we can start a new one called EC114 Lab 2, which will be a text file. So for this lab we will use the world dataset, which we will bring into Stata here. So some of the commands you will be using take an if clause, an if condition that you are imposing in status to do whatever task you're interested in. So here we want to browse our data matrix only for the cases where GDP is bigger than 390. So GDP is, we can go and look here, GDP 08 is measured in billions of US dollars, and is retrieved from the World Bank, and we can just browse our data matrix if for the observations in which GDP is bigger than 390. So if we run this, we get all our variables because we did not specify which ones we wanted to see in particular, and for all the observations in which GDP 08 is larger than 390. So if we select all the variables here, we untick the box and we are only interested in looking at GDP to confirm that the if condition worked. So for all these observations, it is the case GDP is bigger than 390. If we only want to look at the variable GDP, rather than unticking all those boxes, we can just simply run this command, and we say that we want to browse GDP 08 if GDP 08 is larger than 390. If we wish to browse our data matrix for only specific cases in which GDP is equal to a particular value, we use the double equal sign. So after an if condition, we always have to use the double equal sign if we mean to specify an equality condition. So here we want to browse all our data matrix if GDP is equal to 14,200. If we run this, we get only one observation, the United States, and we get all the variables for this observation. Now, when using the if conditions, you should be aware that sometimes if there is no data to be shown, you get an empty data matrix, because in this case we cannot have a GDP that is going to be negative. So if you impose that condition, here GDP being equal to -10, we essentially get no observations. You should also be aware that if you look for values that are larger than the particular number, and there is nothing larger than that number but missing values, Stata actually considers missing values to be a really large number. So in this case, if we would want to browse all the countries for which GDP is larger than that of the United States, in our data set we get those countries for which we do not have information, and information is here stored as a dot or a missing value. Okay, so if we want to browse information for which GDP is different from missing, we have two ways of doing it. Stata understands different than by the combination of exclamation mark and equal sign, or the tilde and equal sign. So if we run both of these commands, we get all the countries for which GDP is different from missing. So they are interchangeable and they simply mean not equal to. We can also combine the if condition with other conditions, such as, for example, here we can combine two if conditions. So we want to browse all the countries for which GDP is larger than a particular value and GDP is smaller than a particular value. So this is a restricted set that we're looking at. Or we can look at all the observations for which GDP is larger or equal to a particular value and GDP is different from a particular value. So here, larger or equal to 14,200 and different from missing gives us the United States. If we had not specified this condition, different from missing, we would have gotten all the countries for which we do not have information. We can also combine the if condition with an or condition here. So here we want to look at all the countries, all the observations for which GDP is larger than 14,200 or for which GDP is smaller than 400. Okay, so this is going to give us more than one observation. It's going to give us the United States and then all the countries for which GDP is smaller than 400. Now, some of the commands will take an in clause. In clause simply means we want to look at the observations in which this is true. So here we're using set more off. Set more off is basically going to allow the output window to display all the information even if it goes sort of below the output window. So if when we run this, we're able to look at a list of all the countries here, just listing everything. So we can just simply compare or look at countries and GDP, and we can simply use the in condition saying that we want to look at this particular list only for the observations from 1 to 10. So here we have the first 10 observations, and we can compare this with the data browser. So the first observations: Afghanistan, then Albania, Algeria, etc. We can do the same for observations between 30 and 50, or we could just say I want to look at the first observation and I want to look at country and GDP. So here we have just one observation of Afghanistan. Now, some of the commands that we're going to run, they can take options. So the summarize command is one of those commands. Summarize command is also very useful for general descriptive statistics. So it gives us a bunch of information about the numerical variables that we have. It gives us number of observations, mean, standard deviation, minimum, and maximum of that observation. Now, summarize can only work with numerical data, so if you give it a string variable that we discussed in the last video, it will not be able to display any of the information. So it is important that we are able to transform the information in those string variables into numerical information that Stata can understand, and we'll do that in later videos. So one of the options that the summarize command has is detail. We can look at what are the options by simply typing help summarize, and we will have the help window. So this describes the syntax of the summarize command and how does it work. At the bottom it gives you some examples. So here we simply have to type summarize the list of variables, and then the options are several. So we're interested here in the option detail because it gives us additional information about the variable. And when we run this, we actually get a distribution of the percentiles, we get variance, skewness, and kurtosis. So we have a little bit more information than the previous one. So here, for example, we can compare the median of this variable with the mean, and then from that we can understand how it is distributed. So this is the options for every command will come after a comma. It is also worth mentioning that all this information is stored in Stata. So when you run this command, Stata stores this information. So if we run return list, we can see that all the information that was displayed here is stored with specific names that we can use at later stages, and we'll do that in the next videos. Another way of displaying information from your data set and summarizing it is using a frequency table, and that is done using the tabulate command. So here we can tabulate the variable colony, so we can look at the variable colony here. So it's colony of what country, so the data set is on different countries. Can be colony of no country, UK, France, Portugal, Spain, etc. We have frequencies, percentage, and cumulative percentage here. So we can summarize information in our data, so we can see that, for example, 32% of the observations we have in our data set were colonies of the UK, and 14.6% were colonies of France, 14.1% colonies of Soviet Union. We can also use the frequency tables to display cross tabulations between variables. So, for example, using the variable high GDP and democ regime. So high GDP is simply a high GDP dummy variable. Dummy variable is simply a variable that takes on two values, 1 or 0, and 1 will be for a country that has a high GDP, so above a certain threshold, and 0 for all the other countries. And democ regime basically tells us whether a particular country is a democratic regime or not. So using tabulate and displaying using two variables gives us a cross tabulation of these two variables in our data set. So here, for example, we can see that most countries with a low GDP are not democratic, and most countries with a high GDP are democratic. So this information can also be displayed using column or row percentages. If we use column percentages, we look at the percentages across columns, so we can look at information this way. So for those regimes that are not democratic, what is the percentage of them that have a low GDP, and what is the percentage of them that have a high GDP? So in this case, from those that are not democracies, 72% of non-democracies have a low GDP, and 27% have a high GDP. And from those that are democracies, 36% have low GDP and 63% have a high GDP. We can do the same for row percentages. So for those countries that have a low GDP, what is the percentage of them that are a democracy, and what is the percentage that are not a democracy? And the same for high GDP. So here, low GDP countries, 55% of them are not democratic, 44% are democratic. High GDP, 21% are not democratic, and 78% are democratic. Another way of summarizing information from our data set is to plot the variables that we're looking at. So looking at the distribution of variables is very important in understanding the information that we're looking at. So one way of doing it, for example, so looking at the variable that describes female representation in national parliaments, which is the variable women. Here for two years, 05 and 09. Whenever we use the describe command, we get a description of the variables we're using. The asterisk here is what's called the wildcard. Every time you use the asterisk at the end of the variable, it basically gives you all the variables that have this string in common, women. In this case, we have women 05 and 09 that have this little bit in common, so we can look at all the variables at the same time. So we can look at whether there's some interesting variation between female representation in the national parliament and the countries that we have in our sample. And after this will motivate us to create scatter plots for this. So we can look at the percentage of representation of females in national parliaments, and we can compare it with countries that we know are going to be less prone to have women in parliament. So to make this information visually easier to interpret, we can simply generate a scatter plot. The command is fairly simple: scatter and then the variables that we're interested in using. So in this case, we use the Y variable, women 09, and the X variable here is the year women were first enfranchised. And we can look at to see if there is any relationship between these two variables, either linear or nonlinear. But to make things easier, we can label each of the dot with a country name, and here we use the option after the comma mLabel for each of the dots, and we label the dots by country, and the variable country is here is a string variable with a country name. If we run this bit, we get the name of the countries for each of the dots, and we can look at whether there is any interesting variation or not. If it is the case that we have theoretical insights for variation between representation in Parliament and other variables, we can use them as well. So here we can look at GDP and representation of women in Parliament and whether there are any relationship or not, and there seems to be something going on here, and we can at the same time control for other factors. Here we'll control for whether the regime is a democracy or not, and here we'll control for the electoral system, whether it's proportional representation or not. So if we use these options, we essentially get 4 plots that control for whether the regime is a democracy, no, whether it's a proportional representation system, no, and we have the relationship between GDP per capita and female representation in national parliaments, again with the observations labeled by the name of the country. So you can work on these commands later. I'll show you other interesting ways of plotting different types of variables. So if we're looking at nominal variables, one interesting plot is the categorical plots. If you want to install the command, you simply have to run ssc install and the name of the command. There are plenty of commands that do not come with the initial data package, but you can install them later on. Since I already have it installed, I will use CatPlot on the variable colony, and I will give it a different name because it already exists on my environment. So here we have, it gives you all the categories and the frequency, the same information that we had with the tabulate command, with table of frequencies, but it gives it in a graph. So we can see that most of our observations were colonies of the United Kingdom. Histogram is also a good way of visualizing this information. Very often, because we have nominal variables, we're interested not in the code that they take on the dataset, but on the label, and we can use a few options with the histogram command, and we can label the values by the labels that the variable has. So here, for example, we have Netherlands, none other, etc. When we have interval level variables, such as women representation in Parliament, we can either use a histogram or we can use a kernel density plot that will give us a smooth visualization of distribution of this variable, or we can use a box whisker plot. So these are graphs that you can explore later on. For numerical description of variables, the summarize command will do for the most part, because we're interested in knowing minimum, maximum, mean, median, variance, skewness, standard deviations, and number of observations of our variables. And you can use the summarize command for that purpose. So if we want to store the information that we just produced in the output window, we can simply close our log file and look at it afterwards. So we can actually open the log file in the folder, and and here is the log file with all the commands we used, all the tables that were produced, and it's all stored nicely if you want to read later on everything that we have done. So practice with these commands. I will make the do file, and so all the materials used for this lab, I will make them available in the description of this video.